So the question is, we said white-footed mice are chock full of this bacteria. They are just afloat with, I mean, they're having like wild sex parties in the field. They're reproducing left and right. They're reproducing young. They're reproducing often. And yet, I mean, they seem to be doing okay for themselves. But they are full of this disease-causing bacteria. Now, here's the thing I want to ask you. Does anybody here think they're a little bit better than a mouse? I'm way better at being a human than, I mean, I'd actually make a lousy mouse, but I kind of, you know, I'm kind of impressed with myself. I got thumbs. I can pick things up. That's pretty impressive.
You can pick things up though.
They don't, well, okay, but mice, they can't do a whole bunch of stuff. But they are running around with this bacteria in their bloodstream. A lot of people in here said they knew somebody who had Lyme. Okay. You actually had, do you have it currently, or are you considered, you took the antibiotics? Okay. Mrs. Miller has had it. So in college, a good friend of mine, and Brett graduated a little ahead of me, and he was a big, strapping, outdoors kind of guy, 6 feet tall, big shoulders, hiker, backpacker, kayaker, you know, just an active, healthy guy. He graduated with his bachelor's from YSU. He was headed to grad school in the fall down in Athens. And the month of June, he didn't get off the couch. And it was his roommates who said, like, dude, something is wrong here. He was sleeping 20 hours a day. He was exhausted. He couldn't move. And he had these, like, horrible headaches. And he was just, you know, he was, like, all fuzzy and foggy and just kind of like, I mean, this was not him. He's a really smart guy. He's a really active guy. He's a healthy, big guy. And, you know, his friends were the ones who were like, no. You need to go see somebody. And this was in the 90s. Nobody knew what Lyme disease was in Ohio. It was not common. Now, fortunately, he did get diagnosed. He took the doxycycline. I think he was on it for like a month. He was fine. But, I mean, this is this huge, strapping, strong, outdoor kind of guy, and it kicked his butt. Is anybody else a little offended that a 2-ounce mouse is fine with this? Are you a little bit perturbed about this, Skylar? You're sitting back there nodding when I'm describing his symptoms. Like, yeah, this will kick you in the tuchus. This will lay you out. And that's in the short term. I mean, I know somebody who had long-term Lyme, and he's got permanent joint damage. How many of you enjoy riding a bike or running or going and walking or just being outside and being active? Imagine if we replace your knees with the knees of a 75-year-old. Like in the course of a few months. That's what Lyme disease can do to you. This bacteria can mess you up. We got a 2-ounce mouse running around chock full of it. What gives? Kill it. Well, so here's the interesting part. And I guess I'm drawing a purple mouse. There we go. The interesting part, there's my little mouse.
Oh, I got really confused on where you were going with that until the bottom part came up.
It's a little mouse. So anyway, there's my adorable little field mouse, my little Paramiscus lepuscus. They are chock full of this bacteria. So how long do you think white-footed mice live in the wild? What do you think? It's a reasonable estimate.
A couple months.
You think a couple months? 2 or 3 years? Okay. On average in the wild, they live for 1 year.
I was going to say a year.
Okay. You basically have 100% replacement of the population every year. Mice are born, and by a year from now, they're probably dead. They're the ultimate prey species. Everything wants to eat them, remember. Now, they have done work where they've taken wild white-footed mouse and put them in a laboratory setting in a nice, safe cage, you know, and there are no predators, and they get 3 meals a day, and life is good, and they can live 2 or 3 years in that setting. But in the wild, they never make it to old age. Something eats them first. But the mice that they had in lab settings that were in a nice, safe cage, getting, 3 squares a day, were full of this bacteria, and they're fine. They are absolutely fine. And they've taken other mouse. Who here's ever had pet mice? Okay. I'm thinking about getting a mouse tank for the classroom. I don't know. I would like to. We'll see. You don't have to look at it, Courtney.
Mine was named Spanky.
Well, okay. I had one named Black Bottom and one named Stink Bum. It's in them. That's a great question because I wanted to find out, like, where do they pick up the bacteria? They're either, so I couldn't find any good data on this. There are bacteria that transmit from mother to offspring in utero, and so they may be born with it, but then they're also in close contact with other mice's saliva and feces. They're nursing on their mom. So there are lots of places where they could be picking it up from their parents, but they are all chock full of it, and they're chock full of it pretty young. So I don't know if they're born with this bacterial load or if it's something that they get pretty early. So they took domestic mice, pet mice, lab mice, which are a different species. They're actually a different genus. They're not closely related. They had wild white-footed mice in one nice safe cage, the domestic mice in another nice safe cage. They infected the domestic mice with the bacteria, and within, weeks, they began to show arthritis in their joints. They would lay down and sleep in their cages. The wild mice are still like running on their wheel 20 hours a day. I don't know what's wrong with you guys. They're fine. They don't show any cardiac damage. They don't show heart damage. They don't show any symptoms of joint damage. They don't show any symptoms of fatigue. They are literally okay with this. Because I had thought initially when I was starting to research, I thought, well, maybe it's just because they don't live very long. Maybe they don't live long enough for the bacteria to affect them. No, it affects domestic mice. But it doesn't affect them. The question doesn't have an answer. No one's quite sure why this is. Now, there's this term coevolution, and clearly the mice and this bacteria have co-evolved to some degree. So the only mice that survived are the ones who were okay with this bacteria in their body. The ones that weren't were too weak, too tired to reproduce. They were too tired to join the sex party in the field. They didn't have any offspring. So, there's some of that. But there are also questions about, like, what in this mouse's immune system allows it to live with this bacteria? And there are some researchers who are saying this is a good thing to look at because humans, if we know why mice can tolerate it, does this hold promise for a cure for humans? I mean, we've got antibiotics for it, but we're going to talk a little bit about when antibiotics don't work. I mean, you got lucky. If you had it and you got antibiotic treatment, my friend Brett got lucky, and they knocked it out. But, people like Mrs. Miller and my other friend who had it long term, you're living with damage for the rest of your life. So how do you prevent that kind of thing? Okay, so do you have questions about the white-footed mice? Let's clarify the words vector, host, reservoir, and pathogen. And we'll talk about those a little bit. These guys are a reservoir for the disease. They are certainly a host for the bacteria, but they're not the vector. So they're not a vector for humans. They are a vector for ticks. So the vector is how it's spread from one species to another. The tick is the vector for humans. The white-footed mouse is the vector for ticks.
Okay.
So it is spread, well, actually, no, it's really not, because it's not spread from, yeah. It is spread to ticks from white-footed mice. So yeah, they would be a vector for ticks. But when we're talking about in human terms, they're not considered a vector. They would be a host or a reservoir because they're kind of like the storage place for all these bacteria in the wild. Other questions? That was a good one.
Does it hurt the ticks then too?
No, it does not hurt them. It lives in their bloodstream and they seem to be unaffected. Now that's one. It's probably because they're not a vertebrate. They're not a mammal. And it seems to have an effect on most mammals. It doesn't seem to have an effect on invertebrates. So you're saying, would the mice have been born with an adaptation that allows them to survive having it? Yeah, that's kind of what we're saying, that the mice who have survived are the ones who their immune systems are managing it, and they're just not letting it affect them. So yeah, the mice that have survived are the ones who are born with whatever that adaptation is. This species has somehow passed along adaptations that do enable them to survive Lyme. Somebody in the other class said, well, then could humans do that? Well, we're talking about a species that's basically born with this, or if they're not born with it, they get it almost immediately. So if you infected all human infants at birth with Lyme disease, I'm not suggesting this. But to set up that kind of scenario, you would have to have like all humans being affected or infected, and then the ones that can't tolerate it are going to die. They're not going to get to reproduce. They're going to be too tired. Their joints are going to be achy. They're going to not be able to eat. They're just going to fall over. So in that scenario, we might see coevolution of humans and the Lyme bacteria, the pathogen. But it probably won't happen because most people get Lyme and they either get treated or, like my one friend who got it, he wasn't going to have kids at the point in his life when he got Lyme, so it wasn't going to affect his chances of reproducing. So, other questions? You guys have good ones.